Hello friends. Welcome to the new learning on stress and strain. In this video we are going to learn about stress and strain. Imagine a solid metal bar is loaded by equal but opposite force is called uniaxial load. Because all the applied loads acting along the same line of action. Now the applied to loads pulling the bar and causing the bars to stretch. The internal force will develop within the bar to resist the applied force. Now imagine a cut section across the bar, making an imaginary cut. To keep the bar in equilibrium, the internal force will develop at the mid of the bar. The equilibrium internal force will be equal to the external applied force. This internal force will be distributed across areas of the bar in number of lines. This internal force can be specified in the term stress. The stress is the quantity internal resistive force offered within the body. This can be measured as the applied force per unit area. The C unit of the stress is the force is Newton per square meter. The Newton per square meter also called as Pascal. The normal stress is the stress develops normal to the square cross-section R of the applied force. Sigma is equal to the force per unit area. For example, say a material mild steel of strength 200 megapascal. When the stress exceeds the 200 megapascal, the material will get fail. That is, failure occur when the induced stress is reaches above the material's strength, it will fail. For example, a shaft of diameter 20 mm, its cross-section area will be 314.16 square millimeter. Now the force is equal to the stress into area. That is 200 into 314.16 is equal to 62,831 Newton is equal to 62.83 kN. Unit conversion: 1 megapascal is equal to 10 power 6 Newton per meter, and the square millimeter is the unit of area. Therefore, the unit of the force is Newton. The normal stress is classified into two types: tensile stress and compressive stress. The tensile stress will be calculated for the tensile load application, that is tensile force per unit area. The tensile stress sign is positive. Similarly, the compressive stress will be calculated for the compressive load application, that is compressive force per unit area. The compressive stress is negative. This stress will move in parallel lines across the area in normal cross-section bars. When moving the curved beam, both the tensile and compressive stress will act at the top and bottom of the layers. Strain. Strain is the deformation that occur within the body due to the applied load. Imagine a rod fixed at one end and a tensile load is applied at the end. Due to the load, the rod extends a length of del L. Now the strain can be calculated as del L, that is change in length, divided by L, that is original length. This strain is a non-dimensionless quantity. The normal strain can be a tensile or compressive stress. The stress and strain relationship can be represented in stress-strain diagram. It will be differed for different materials. This curve can be plotted by holding the stress in y-axis and strain in x-axis. For a material, the stress-strain diagram for a material can be performed by preparing the material as per ASTM standard-sized samples and applying the axial load. The stress and strain will change with respect to the applied load. The stress-strain for the ductile material will be like this. In initial region, the stress will be more than the strain value. In this region, the stress and strain will be linear. In this region, the object will completely reverse to the original shape after the deformation. This said to be an elastic region. This linear relation can be defined by the Hooke's law. The stress will be proportional to the strain. The ratio between the stress and strain is called as Young's modulus or modulus of elasticity. It is an important property of the material. This Hooke's law is applied only for the smaller strain. It will not be no longer linear relation for the higher strain rate. Other than elastic region is called plastic region. In this region, the deformed object will not regain its original shape. It will be permanently plastically deformed. Now let us see the behavior of material in related to the stress and strain. The material chosen for the understanding is mild steel. Let's have the stress in y-axis and strain in x-axis. The stress-strain curve for the mild steel material will be like this. The first region from O to A is called proportional limit. Stress will be proportional to the strain. In this region, the stress will increase higher rate than the strain rate. The region A to B is called elastic limit. Up to this limit, the object will regain its original shape after deformation. The region B to C is called upper yield point. It is a point, the maximum load or stress required to initiate the plastic deformation of material. Next, the point D is called lower yield point. It is a point where a minimum load or stress required to maintain the plastic behavior of material. The point E called ultimate strength. In this region, the material will bear the maximum amount of stress a material can withstand before it breaks. Final point is F, and the object will break at this point. So far, we discussed the normal stress. Imagine a seine rod. Now the force is acting lateral direction of the axis. Now due to the load the rod will slice like this. The induced stress is called shear stress and the strain is called shear strain. In this, the shear force will be developed parallel to the area of the rod. This shear force will be common in the bolt and nut arrangements. Imagine two plates are bolted like this. The tensile forces acting like this. The forces will be resisted on the bolt and will tend to shear. Due to the shear force, bolt will shear like this. The sheared area will be used to calculate the shear stress. Shear stress is the ratio between shear force and cross-section area of the bolt. In case two bolts were used, double areas will resist the force. Therefore, the cross-section areas should be doubled for the stress calculation. The shear stress formula is shear force divided by 2 into area. A box is acted upon the shear forces at the surfaces. It will tend to slip like this. The stress will be developed due to the shear force is called shear stress. Due to the stress, the object will slide and it will change its shape and forms the strain. The Hooke's law is applicable for shear stress and strain also. The shear stress can be calculated by using this formula, that is shear force divided by shear area. Thank you.